Hi, my name is Yatharth Gupta. I'm a PM in the Windows organization for Wi-Fi, and I'm here with Vishal Mhatre, and we're going to spend some time talking to you today about Wi-Fi Direct and Wi-Fi Direct services in Windows 10. Today, we'll spend some time talking about what is Wi-Fi Direct and Wi-Fi Direct services. What can you do with this technology, with these APIs? What can you build? What are some of the very interesting scenarios? We'll talk about what's new in Windows 10. Then we'll walk through a demo. We'll show you how all of this comes together. After that, Vishal is going to walk you through how simple and easy it is to write this code. And then we'll give you a couple of tips on debugging. In today's world, most applications connect to the internet and provide a service to the user, such as Facebook or Yelp. However, there is a class of apps and devices that can benefit from direct connectivity. Wi-Fi Direct and Services is a technology that provides this direct connectivity. It allows for PCs, phones, or other devices running Windows to connect to other PCs, phones, or devices. The unique value here is that the devices do not need to be connected to the same access point or even to a network. They can just talk directly with each other. Once you are connected, once these devices are connected, you have a very high bandwidth pipe available to you. So you can pump a lot of data. You could move videos, you could sync a PC and a phone. And it's not just limited to two devices. We talk peer-to-peer, but you could connect one device to many devices. Some of the interesting things that are built on this technology are things like games. So let's say you wanted to build a chess application that two people could use in a park. They need to be able to find each other. They need to be able to connect to each other. These are some very interesting things that start shaping up when you have connectivity directly between two devices. You could think about applications such as PCs or phones connecting to devices to control them. So, you have a printer, you bring it out, you want to configure that printer. You could do that over Wi-Fi Direct. You could think about long tail devices such as a quadrocopter. You want to be able to communicate with this, you want to be able to send and receive messages from it, and you want a long range, the range that comes with Wi-Fi. You could do this using Wi-Fi Direct and services. Before we start getting into the details, I wanted to explain the difference between Wi-Fi Direct and Wi-Fi Direct services. Both of these technologies are industry standards. You could use these technologies to talk between a Windows device and another Windows device, or you could use these technologies to talk between Windows and any other device that you're building. Wi-Fi Direct came first. It allows you to find another device, pair with it, connect to it, and communicate it. What Wi-Fi Direct Services adds is an additional layer on top of it. So you can actually find the service running on the remote device. For example, if you were writing a game application, you would from a PC find another PC, and that's not very valuable because the PC may or may not be running the game. With Wi-Fi Direct Services, you could actually find other people who are playing the same game in the vicinity, so you could connect and communicate with them. Let's talk about Windows 10, the API, and what's new. The first big change from Windows 8.1 to Windows 10 is that we've added Wi-Fi Direct Services. This concept did not exist in Windows 8.1. This is a new emerging technology, so we thought it was prudent to add it to Windows 10. The second thing is we have significantly enhanced the API set for Wi-Fi Direct. And this is based on feedback that we get from ISVs, things that they want to build, things that they want to do different, how it would help them complete their scenarios. So let's talk about the API. In Windows 10, which is in sharp contrast from 8.1, the apps have complete control over the experience. So the app can go and find a device. The app can go and pair with a device. And pairing is important because we use a shared medium, so trust needs to be established. The app can go and connect. The app can communicate with the device. And you know what? If you're already getting bored, all of these are concepts that do not need to be exposed to the user. In 8.1, you had to use our user interface to go and find the device and then use your application. And now you can completely do this from within your application. The second thing that we've added as an enhancement or an update to the API is bidirectional control. In 8.1, when you used Wi-Fi Direct, you always had to find from Windows. You could find other devices from Windows, but you couldn't find Windows from other devices. We had one directional support. With Windows 10, you can write an application that says, go find me other devices, or you can go into a mode that says, hey, let other people find me. Let other people find me as a device. Let other people find me as a service. And to get into a little bit more details of how powerful this API is, applications can send custom information elements, and they can read and write these elements. If you're familiar with Wi-Fi, you would know that information elements is a standard extensibility mechanism. So let's say I was building an application for a device, and I can find the device. The standard allows for me to know the name of the device and the serial number, but in my application I wanted to show the color of the device. The device can send an information element that can be read by the application that knows the color, so you could have better experience for the user. You can read and write these information elements. We've also thought a lot about what happens to all those devices out there that want direct connectivity but do not have Wi-Fi direct support. We've added a mode so that Windows can come up as a legacy AP or a standard AP. And what would happen when you go into that mode is any device that has Wi-Fi could connect to Windows just as a network. We've also added low-level control, and this is again something that you would be familiar with if you're familiar with Wi-Fi Direct, but geo-intent is a very low-level concept in Wi-Fi Direct, and our new API is powerful enough to let the application specify these parameters. But you know what? Enough with the talking. Let's get into demo and see what all of this looks like. What we're going to show, we've decided to show a Swiss knife application. This application is going to show you all the different parameters that you can move, edit using your application. You don't need to use all of them. What we want to demonstrate is what all is available to you. We won't be going through each one of them. What we will do is we will go through a demo of Wi-Fi Direct and then Wi-Fi Direct Services and show you how services is different than direct. So let's get to the demo. I'm going to hand it over to Vishal, who's going to talk a little bit about the API and then show the demo.
The Wi-Fi Direct API has two entities with differing roles in it. They're called as the advertiser and the connector. The advertiser advertises itself over Wi-Fi, and the connector discovers the advertiser and connects to it. For this demo purposes, my PC is going to be the advertiser, and Yatharth's PC is going to discover my PC and connect to it. So let's go ahead and start an advertiser. To start an advertiser, we need to turn on the listen state of the PC. Let's go ahead and do that. We then start the advertiser. At this point, my PC is discoverable and other PCs can find it and connect to it. So Yatharth, why don't you discover my PC and connect to it?
Let me go here and click on Get Devices, which calls into the API to find other devices. Oh look, I found Vishal's PC there. Should I go ahead and try to connect to it?
Sure.
Let me click that PC and let me hit connect. And Windows is asking me if this is okay. I'm going to say yes.
And I see a connection request from Yatharth. I'm going to go ahead and accept his request. Windows is now asking me if it's okay to accept this request. I'm going to say yes.
And we're connected. So what we just showed you is a direct connection between these two PCs. Note, you could do this between a PC and a phone. You could do this between a PC and any other device. These devices are not on the same network. In fact, they're not even connected to any network. So going back to our park scenario, where you want to write a chess application, you could find another PC and you could connect to it and you could start playing chess. You do not need to show all these technical aspects in your application. This is to illustrate the diversity of the APIs that we offer. Why don't you go ahead and send me some data? Let's see how the data exchange looks. And we're transferring some data between both these PCs. Next, what we're going to show you is Wi-Fi Direct Services. It's going to look very similar and we'll articulate the differences in there. Cut. So we got to disconnect.
Yeah. Just close the device. Or do you want to do it again, or was it okay?
No, I think it was okay.
Okay.
I think it was okay. That was great.
Okay. So let's go.
So we done with that?
One more. We have another demo.
This is the second demo. Yeah. Okay.
Okay. What we're going to show you now is Wi-Fi direct services. In the previous demo, one PC found another PC. But with Wi-Fi direct services, you can actually find a service running on the PC. So Vishal, why don't you go ahead and let's create a build service on your PC. And is that advertising itself now?
So my PC is advertising the build 2015 service, and it's available for other seekers to discover it and connect to it. So Yatharth, why don't you discover my service and connect to it?
So I'm going to go and look for the build 2015 service. And if you were building applications, both your applications would already know the service that they were trying to find each other. So the user doesn't need to type in all of this. This is something that your application can do. So should I hit get service?
Sure.
So I'm finding services. And look, I found somebody else running this service. I'm going to select this and I'm going to hit connect.
I see a connection notification from Yatharth. I'm going to go ahead and accept his request.
And are we connected now?
We are connected over Wi-Fi direct services now.
So I'm going to click check this session. And how do I send some data between both of these?
So you need to basically add a port.
Okay.
So you do that by choosing a random port number here and then just clicking on the TCP button here. At this point, we are connected over L4 and we can proceed with sending data to each other.
You can see data flowing between both these PCs. Again, the big difference here, these demos look similar, but the big difference here is, are you trying to find a device or are you trying to find a service running on the device? If you were building games, you want to find a service running on the other device because you want to know who else is playing in that game or is in the game lobby. If you're trying to find just a TV or a phone or something, you would use Wi-Fi direct. So let's talk about the code that powers these applications. Vishal, if you could walk us through what it takes to build one of these applications.
Sure. So from the demo app, we saw that the Wi-Fi Direct API had two distinct roles. One was the advertiser and the connector. The connector connected to the advertiser. Let's take a look at how to write the advertiser. To start an advertiser, we instantiate an object of the Wi-Fi Direct advertisement publisher class. The next thing that we do is to turn on the listen state for the advertiser. We set that by setting the listen state discoverability property. Proceeding, we enable the advertiser to accept incoming connection requests from the connector. We do that by instantiating an object of the Wi-Fi Direct connection listener class. We assign a callback to the connection requested event handler, so when a connector tries to connect to the advertiser, this event handler is fired. We'll take a look at the connection handler event code in the next few slides. The final step in starting the advertiser is to call the start method on the publisher. That's it. At this point, your advertiser is advertising over Wi-Fi and is ready to accept incoming connection requests from the connector.
So what you're saying is if I wanted to make my PC discoverable, it's as simple as doing these 4 steps.
Correct.
All right, let's talk to these guys about what happens next.
Let's take a look at the connector side.
So this is the other side. This was my PC which was trying to connect to your PC.
Correct. To connect to the advertiser, we need to find the advertiser first. This can be done by creating a query string for finding Wi-Fi Direct devices. This query string can be created by calling the getDeviceSelector method on the Wi-Fi Direct device object. This query string, also called as a device selector, is then passed to the findAllAsync method on the device information class. The findAllAsync method returns you a device information collection object which contains device information objects which represent the Wi-Fi Direct devices found nearby. The connector then proceeds by selecting the desired Wi-Fi Direct device and connecting to it by calling the fromIDAsync method on the Wi-Fi Direct device object. The fromIDAsync method also takes an optional connection parameters object on which certain connection properties like geointents can be set. The fromIDAsync method returns you a Wi-Fi Direct device object which represents a connection to your advertiser. Finally, the connector can proceed in obtaining the remote and local IP addresses by calling the getConnectionEndpointPairs method on this Wi-Fi Direct device objects. With these IP addresses, the connector can then establish a socket connection with the advertiser.
So on one side, we started being discoverable. On the other side, we found the device and tried to connect to it. Is there some more code on the first side where I accept the incoming connection?
Yes, the next slide, I'm going to talk about that. So we remember that we had set a callback handler on the advertiser for accepting incoming connection requests from the connector. Let's take a look at how the code looks. So when the connector tries to connect to the advertiser, the connection requested event handler is fired. The advertiser can then retrieve this connection request by calling the getConnectionRequest method on the requested event args. The advertiser at this point can either choose to accept or reject the request. For this demo purposes, we are going to accept the request. The advertiser can then call the fromID async method on the Wi-Fi Direct device class and pass in the device information ID obtained from this connection request. The successful completion of this method returns you a Wi-Fi Direct device object that represents a Wi-Fi Direct device connection to the connector. The advertiser can then obtain the IP addresses and proceed with the socket connection. At this point, both the advertiser and the connector are connected over a socket and begin communication.
All right, so that was Wi-Fi Direct. And you know what? If it sounds like we rushed through that, or if you did not get it, we're going to share the full source code of the sample that we demonstrated here, so you can start playing with it and building it into your own application. But let's quickly also walk through Wi-Fi Direct services. You know, we showed two demos, Wi-Fi Direct and Wi-Fi Direct services. Let's walk through Wi-Fi Direct services.
Sure. So similar to the Wi-Fi Direct API concept, the Wi-Fi Direct services has an advertiser that publishes a service over Wi-Fi, and the seeker basically discovers this service and connects to it. Let's take a look at what it takes to start an advertiser. To start an advertiser, we instantiate an object of the Wi-Fi Direct service advertiser class. We pass in the service name as a parameter to this class's constructor. Next, we assign a callback to the session requested event handler on the advertiser, which gets fired whenever a seeker tries to connect to your service. The final step in publishing a service is to call start on the advertiser. That's it. You now have a service ready for accepting incoming connection requests from other seekers.
So if I was writing a game, this is what I would do in the game lobby. Like if I'm waiting for other people, I want them to know that my game is running. Instead of the service name, like I would fill that variable up with contoso.game, and then everybody else running that game could find me.
Correct. Let's take a look at what it takes to start a seeker. To connect to a service, the service needs to be discovered first. To discover a service, we need to create a query string with that particular service name. That can be done by calling the getSelector method on the Wi-Fi Direct service class and passing in the service name. This query string, also called as the service selector, can then be passed to the findAllAsync method on the device information class. The findAllAsync method would return you a device information collection object that represents the nearby services found. The seeker can then proceed to connect to the desired service by calling the fromID async method on the Wi-Fi Direct service class.
So the big difference between Wi-Fi Direct and Wi-Fi Direct services is I would only find people who have the service running.
Correct. So the fromID async method on successful completion returns you a Wi-Fi Direct service class that represents this Wi-Fi Direct service. The seeker can then proceed to connect to the service by calling the connectAsync method on this object. On the successful completion of this method, you get a Wi-Fi Direct service session object that represents a connection to the service. The seeker can then obtain the local and the remote IP endpoints from this object and proceed with socket connection. Let's take a look at what it takes to accept incoming connection requests from other seekers. So we had assigned a callback to the session requested event handler on the advertiser. This callback gets fired whenever a seeker tries to connect to your service. The advertiser can obtain this session request by calling the getSessionRequest method on the requested event args. The advertiser can then connect to this seeker by calling connectAsync and passing in the device information object obtained from the session request. This method returns you a Wi-Fi Direct service session object that represents a connection to the seeker. The advertiser can then proceed in obtaining the IP addresses and connecting over a socket to the seeker.
So if we had to summarize both of these APIs, right, you have two basic rules. The fundamental thing is you have one side trying to be discoverable, the other side trying to find it. You make yourself discoverable and then you wait for incoming connections. That's one role. And the other role is you find people who are already discoverable and connect to it. And what we've demonstrated is both sides of the role. If you were working with one Windows PC and something else, you only need to implement one side of this role. So we walked through the code. Let's talk about, as people start building these applications, what are some interesting tips or tricks that people could follow? There are two things that we would advise. The first one, Windows works on a diversity of PCs. They work on old PCs, they work on new PCs, they work on PCs with hardware that has advanced Wi-Fi and others that don't. So the first thing that you want to do before you start building applications is you want to make sure that your PC actually supports this capability. And in Windows 10, we've added a command. I'm not going to read the whole thing, but you can run that command on your PC and you can see if Wi-Fi Direct and services are supported. You'd see an output like we show here. The second thing, if you're going to be working with devices and if you're not able to get connections through or if they're failing, a wireless sniffer is your best friend. A wireless sniffer shows you what goes on over the air. So, packets coming out of this PC, how do they look over the air and how do they go to the other PC? So let's look at what a sniffer capture shows here. What you can see here is a Wi-Fi direct connection. It shows you a PC trying to connect and pair with another PC. We're going to include a sample capture with this presentation so you can download that and you can look at what a successful connection looks like and play with it. These messages that you see over here, they're all very well defined in the industry standard. So if you have questions about the messages, I would recommend you start reading the industry standard. So let's recap about what we've spoken about today. Wi-Fi Direct and Services industry standards that allows interoperability between Windows and non-Windows devices. These APIs, they allow you to create a direct connection without needing connectivity to an API or to the internet. We think that some of the most interesting use cases are games and applications that allow you to control their devices, and utilities, things such as file sharing. These are things that we have come up with. We'd really like to understand what you are going to build. If you need information about the standards, not about the APIs, if you need information about the standards, they're available from Wi-Fi Alliance. And all information about this API and these samples, they're going to be published here soon on MSDN. We'd like to thank you for listening to us and hope you enjoyed our presentation. We look forward to seeing your apps in our App Store. Thank you.
Thank you.